Good morning to all. On behalf of ATAL sponsored FDP organizing team, we heartily welcome all the participants and today's session expert, Dr. Vijaya Kumar Manupati. It's my great privilege to introduce Dr. Vijaya Kumar. He is currently working as an assistant professor in the Department of Mechanical Engineering, NIT Warangal. He received his PhD in the Department of Industrial and System Engineering from the Indian Institute of Technology, Kharagpur. His current research interests include intelligent manufacturing systems, cyber physical systems, sustainable supply chain, and healthcare systems. He has published more than 86 publications, which include prestigious journal like International Journal of Production Research, Computers and Industrial Engineering, International Journal of Advanced Manufacturing Technology, Journal of Measurements, International Journal of Computer Integrated Manufacturing, etc. He is acting as an international reviewer for more than 30 peer-reviewed journals. Currently, he is acting as an editorial review board member of International Journal of Sustainable Entrepreneurship and Corporate Social Responsibility, International Journal of Web Portals, that is IGI Global Publications. He received an early career research grant from Department of Science and Technology for his research work on telefacturing systems. He is a member of the Institute of Industrial and System Engineering, Institution of Engineers India, life member of International Association of Engineers US, and also acting as a technical committee member of various international conferences. He has been instrumental in organizing various international conferences and FDPs. Now we request to sir, please enlighten us with your great knowledge and experience on the topic of machine learning. Over to you, sir, please.
Thank you, Deepak Kumar, for reading my profile in detail. Thank you so much. And I also thank the organization committee members for inviting me for this wonderful program. And so I would say with so with regards that this particular program, that is IIoT, industrial IoT, is really a cutting edge technology for current era, and it's a very right way and at right time this program is organizing. It's my pleasure to be part of your team. Thank you so much. And with these small words, I would like to share my PPT now for giving my talk in this 1.5 hour. Can you see my screen? Could you able to see my PPT?
Yes, sir.
Yeah, great. Yeah, myself, Dr. Vijay. I'm currently working in NIT Warangal, and today I would like to give a talk on machine learning introduction and applications. So as I see already the program chart before me, some of the learned expertise gave a wonderful talk on some of the well-known topics of IoT voting with respect to like Industry 4.0, cyber physical systems, etc. If I want to talk something on machine learning, I would like to touch some aspects of already discussed experts, and then I will dive you towards the machine learning introduction and its inceptions, etc. And my concentration on today's talk is on two different contexts. One such context is on manufacturing systems design. The other context is on supply chain management. So I would like to integrate these two different applications in the context of machine learning. So, and I also would like to give you some future directions and future factories, applications with respect to the machine learning. That is what the broader idea of my talk in this 1 or 2 hours. So therefore, my agenda could be like this. I'll talk in detail about the introduction to machine learning. And of course, I will give some glimpse because of different variety of participants available here. I would like to give a small introduction on supply chain management before going to the real life applications of supply chain management applications with respect to the machine learning. And of course, I will give some manufacturing systems applications uh, in the context of machine learning, artificial intelligence, and IIoT integration approaches towards solve these kind of real life problems. That is the idea and total agenda of my talk on today. So with that, so my talk will start with this particular question. The question here is, what is buzzing across recent industrial world? Of course, everyone knows. The context is also same for this today's program. You may say, sir, it could be industry 4.0. Somebody may come up and say that yes, it could be cyber physical systems. And somebody may give a word like IoT, and somebody may say that IIoT, etc. Yes, of course. These are the buzzing words across industries and across the world. So therefore, industry 4.0 of today context. So why it is so popular? Of course, some of the learned experts in the previous topics may talk much about this. I would like to give a small, a glimpse of why this industry 4.0 with respect to current like artificial intelligence, machine learning, IIoT, IoT, etc. You all know well known about industry 4.0 because of cyber physical systems, therefore cloud computing and cloud manufacturing, therefore IoT and IIoT. Yes, this is well fact. But my question here is, why it is only industry 4.0? Why not 5.0? And I want to go further, why it should not be 6.0? Yeah, my question is having some validity here. Why it is validity here is, you see the industrial revolution 3.0 and the current technologies development happened over the years. So the technologies was rapidly developed up to industry 4.0. There is a quite long time has taken at industry 4.0 where it not supposed to be at that point. Therefore, researchers, scientists, and well experts in this area are talking about why it is 4.4.5 and why not 5 and 5.5, etc. Of course, in European world, already the 5.0 context is already there, and 4.0 is already is going in a much mature level. So therefore, in India, we are into this 4.0 of some reasons. In the next slides, you will understand why we are towards the industry 4.0 and why we need to emphasize more on this according to the context of the Indian policies, Indian manufacturing units, Indian kind of context. And not only that, I want to give some more glimpse. That is, in industry, nowadays, it's not only the 5.0, not only the technology giving a major edge. There's something you need to concentrate on. The something that is, the parallelly when you are developing the technology, you also need to concentrate on something else. The something else is the sustainability goals. Of course, technology is increasing the productivity, efficiency, effectiveness of the material and technology development. Various processes, various technology. All these are developing. Well, fine, but parallelly, you need also concentrate on the other side of the coin, that is called whether you are sustainably doing this work. Are you developing the technology sustainably? Are you developing the product sustainably? Is your industries are efficient and effective in a sustainable way? That means The sustainable efficiency or sustainable productivity, are you achieving or not? These also one of the primary factors that you need to concentrate on, along with the industry 4.0 technologies. That is the current buzzing across the recent industries. When I said something about the manufacturing systems design or the supply chain management, so these are much, much, much bigger, playing critical roles. For example, if you are processing certain industries, you need to concentrate on something called energy efficient processes. When you are developing a supply chains of the industries, or when you are processing in the supply chains should be sustainable supply chains. So therefore, yes, these the sustainability goals along with the industry 4.0 technologies, this integration will give a better outcome of the recent world. But whether this is sufficient, I don't think this is sufficient for future factories or future manufacturing systems or future industries. You will understand why that when I'm discussing about the applications of different applications in manufacturing systems and different use cases. You'll certainly understand this is not sufficient for us. It is something else. So let us see in detail about it. So with this introduction, therefore, the manufacturing systems in the left hand side require much flexible. The meaning of the flexible is the ability to withstand the variations in demand. The manufacturing industries are integrable. That means it need to enable different cyber physical systems devices, and it also need to integrate with the different modules in the sense, maybe the project management module, maybe different modules like production module, maybe the maintenance modules. All these need to be integrable. That kind of manufacturing systems are nowadays required. That kind of industries we are required. So when you are doing this, when you want to enhance these capabilities, there is also something very important thing you can see, that is called interoperable. That means the systems are, because of the distributed manufacturing environments, because of the enterprises located in different areas, when it need to integrate properly, it has to taken care of different devices, and the different devices is having different outcomes, different databases, different technologies. So all these you need to bring in a common platform. When you want to bring all this into a common platform, imagine how difficult this one is. So therefore, you want to achieve that by using that certain thing called interoperability of the systems. Therefore, the manufacturing systems nowadays you are looking in the industries are not the ordinary manufacturing systems. It should be reconfigurable manufacturing systems. It could be flexible systems. It requires certain scalable nature. So scaling up and scaling down of the manufacturing systems, tools, machines, resources must be required when you are talking about the future factories, when you're talking about the industry 4.0, when you talk about the cyber physical systems, when you talk about this some part of smart manufacturing systems. So this is what the key characteristics now you can see, and you want to enable even to function these industries properly. So when you want to adopt these key factories or key characteristics into the industries, there is a very interesting aspect you might be looking over nowadays. That is called the diagnosability of the particular system. So you might be heard some terminologies like prognostics and diagnostics. So the prognostics part will be taking care of the other side, and the diagnostics part will be taking care of the other side. So this prognostics and diagnostics of the manufacturing systems, in fact, in the entire supply chain is much essential. So nowadays, that is why lot of emphasis is on, or lot of stress is on the maintenance management of the factories. previously the maintenance management is there, but the lot of stress is not put by the number of industries on this part, that is called diagnosability. Because nowadays the machines are loaded with the IoT and IIoT, and you are making the traditional manufacturing systems into a cyber physical systems or knowledge based systems. So therefore, monitoring of data every time, cleaning of the data every time, checking the status of the data of every time, and then removing of unwanted data or unwanted information. So this require a step to step process of diagnosability. So therefore, this diagnosability or the maintenance management role has become much more nowadays. So that is one part. So therefore, these characteristics, the key characteristic, what I said, is much essential, and this should be enabled into the manufacturing system. That is the left-hand side of the story of the manufacturing system. Let us see the right-hand picture, what I have given here. You know very well about supply chain management. If somebody don't know, so the supply chain consists of, right from the beginning to supplier and to the end customer, there are different modules inside. One is after the supplier sending the raw material to the manufacturer, it goes to the manufacturer, and in the manufacturing units, the raw material will be transformed into a end products. These end products later shifted to the customers with the different, again, like for example, retailers may play a role or the distributors may play a role. So these are the different stages where the supply chain works. But whether this traditional supply chain is much sufficient according to Industry 4.0 context, I don't think so. Because so now, according to the Industry 4.0, if you observe the figure from the right beginning, like raw material from the supplier side, it is going to the material transformation, that is at the manufacturing side, and then the component fabrication is happening at the manufacturing units, and then of course in the manufacturing units or the related manufacturing units, the sub product assembly may be taken place, and then the distribution will be taken will goes to the retailer or the wholesaler, and in between suppliers, etc., and it goes to the user. From raw material to the user, that is what we were seeing as a traditional supply chain management. But what user is doing is, after he finished the product, it is coming back to as a waste. Till last decade, we done this kind of process. We are not at all bothering of something called this waste. But according to recent industries technology, according to recent industries key characteristics, we understood there is something else need to be done at this waste. Therefore, the manufacturing units become remanufacturing units. The distributors are become the redistributors, and the user become is not an end user. He is become only the user, because the end product what the user will give, that will be going back to the, again, any stage of the supply chain. It goes back to the distributors, or it goes back to the product assembly, or it goes back to the manufacturing units, and sometimes it also go back to the supplier who is distributing the raw materials. Therefore, the key characteristics of the supply chain management, that is reuse for repairing the product, remanufacturing, and recycling, these three R's play a critical role for transformation of the waste, that is the end product, to the, again, coming back to its life. And this loop will continue. Therefore, sometimes we used to call it as remanufacturing kind of units. Sometimes we are also calling it as a closed loop supply chains, etc. There are different names given by different experts in this area. So we right now we can call this as a closed loop supply chain, where the different end products which are in waste can also be transformed into its life. Therefore, the products become a sustainable products. So therefore, these are the key characteristics you can find from the recent future factories. Why these are so much of popular? Why these are so much of required for any industries? Because of Industry 4.0's evolution. It transformed the entire, industries. Could be manufacturing industries, it could be service industries, it could be pharmaceutical industries. We need to follow, when you want to follow the technologies, you need to follow, or you need to enable certain key characteristics of each and every technologies, of in each and every systems. That is what we can see at this stage. So now, to do this, that means in the previous slide, that is this different characteristics we will see to identify these characteristics, to understand these functionalities, to enhance the capabilities of these particular characteristics. There is a requirement of certain technologies. Therefore, the Industry 4.0 brought out a very interesting technologies of so of current nature. That is IoT, Internet of Things, cloud computing, cyber physical systems, big data analytics, digital twins, augmented reality, artificial intelligence, machine learning and deep learning technologies, and blockchain technology. So here in this talk, my concentration is on one key supporting technology, that is called machine learning. So therefore, I concentrate more on the machine learning part on today's talk. Of course, but I would like to give you some glimpse of these key supporting technologies at this point. So one is when we are talking about the Internet of Things. You know, recently what happened to the our Indian Airlines security issues? You all know very well about it. That data from last 10 years passengers was theft. It was hacked. So when you talk about Internet of Things, yes, it is a beautiful word. It's a beautiful word that you can use it, and the technologies inside of the IoT is can we keep it up, can retrieve the information from there, could be increase the capability of the machines or the systems or the products. But a coin is having a head and also having a tail. If the head is so beautiful and you also need to concentrate on the tail side, that is called Internet of Things. That is why I quoted an example of Indian Airlines. So when you are looking over Internet of Things, you also have to take care of Internet of Threats, that is the other IoT. So therefore, the key supporting technologies IoT is also brought some understanding about the Internet of Threats, that is called cyber security. So this is one of the key supporting technology of Industry 4.0. The other one could be the cloud computing. You know what is how important this one because of the cyber physical systems. When you talk about the cloud computing, yes, recent limitations on the cloud computing is really is really giving certain doubts on the IoT devices and the cyber physical systems. I will give you a slide with respect to these, some of what are the limitations of the cloud computing. Therefore, other new technologies has overcome this technology. I will give you that anyway. When that slide will come, I will detail about what is the cloud computing and what are the limitations and which technologies has really overcome this cloud computing technologies. So now, cyber physical systems. Yes, you connected with the system and they, IoT devices, sensors, other things into your physical system. It turned into a cyber physical system. Great thing. Yeah, sensors, actuators, all these devices play a major role. Lot of research work is going on this area on the development of sensors, depending upon the product category, depending upon the products, depending upon the resources. You have to enable these particular particular devices so that you can make the physical system into a cyber system in connection with the IoTs and the cloud computing. A beautiful integration can be done with respect to these technologies, right? Fine. So this actually brought something called data, a mammoth of data is generating for every second nowadays because of IoT and cyber physical systems. So how to handle this data? The data is really important, of course. But in the meantime, you need to understand what is that data is, how important that data is, right? And really, this data is required. How much is required? So therefore, data analytics play a major role nowadays to improve the visibility of the data, right? So that is about some information about the big data analytics. Yes, this is also one of the key supporting technology. And the other key supporting technology nowadays you can see that is called digital twins. I have certain examples with respect to this. Therefore, I will give you in details about this digital twin when that slide will come out. In next few minutes, I will be detailed about this. So another key supporting technology that is called virtual reality and augmented reality, as well as AI, ML, and deep learning technologies. So of course, my concentration is on machine learning. I will give you details about AI in some part and machine learning in detail. So therefore, you will understand this particular key supporting technology in deeper side. So the other kind of key supporting technology of Industry 4.0 is blockchain technology. So it's a very fascinating technology. Like when if your supply chain want to be a transparent, the supply chain could be any kind of supply chain. It could be a pharmaceutical supply chain. It could be automobile supply chain. It can be a any kind of service supply chain. If you want to make that particular supply chain is transparent enough, and you want to secure the transactions, then a technology like blockchain technology will improve, and it will give much productivity of the context you are looking for, the context of the problem you are looking for. So therefore, blockchain technology is one such key enabling technology which really do the wonders. What you are seeing in this slide is a beautiful technology is spreading over, right? So correct implementation, right implementation of these technologies at the right time, at the right platform is much essential. And therefore, so here on my talk, you will understand at what point of time, what technology need to be placed uh, in particular to machine learning technologies. So here I have taken one more slide here. This is actually taken from Deloitte and Council of Competitors. So given by Global Manufacturing Competitive Index at in the year 2016. You know, uh, so when you see this one, it was actually given by 500 global executives all across the world, and they have given this index. So they brought it out some of the future importance of advanced manufacturing technologies and the rankings. And there our concentration is on India. Of course, I kept India as an one side, and some of the you know so advanced nations like, for example, United States and Europe and China perspectives with respect to these advanced manufacturing technologies is also keep it here. When you carefully look over here, as I said in the very introductory slide about the diagnostics part, the prognostics and the diagnostics part, right? So yeah, therefore the United States, China, they are taking these as one of the important factor that is called predictive analytics of the manufacturing technologies or advanced manufacturing technologies. Is actually this technology they have given a first priority here. Whereas the smart and connected products, that is called IoT, we are calling nowadays, and of course IIoT, these comes under the priority number 2 for the United States and Europe and as well as India. Let us see our concentration here. The India is looking for at the year 2016. During that time, our concentration is the digital design, simulations, and integrations. And the number two is on smart and connected protocols or products. So that is IoT devices, IIoT devices, etc. Therefore, we are at the right stage now. Yes, we can say by seeing this index and saying this, while we are comparing with the other states, perspectives and their priorities, we can also say yes, we are somewhat matching with the global industries and global nations priorities. So our second concentration is on smart and connected protocols. Our third concentration is on smart factories, and fourth is on predictive analytics. Right. So fine. So we are at the right platform. We are actually imbibing this industry 4.0 into our industries. Then how we have reached. Therefore, I have taken here one more slide with respect to the source of World Economic Forum. According to the World Economic Forum, WEF, what they were thinking about the India and what are the timelines actually we have developed to mature our technologies. So if you see in the left hand side, I have given here Internet of Things, IoT, and 30 billion IoT devices will be in online by the year 2020. That is a priority of the India. That means by the year 2020, our priority is to imbibe all these 30 million IoT devices, and it should be bring in online. And let us see about the red ink portion. That is what my area of concern now, and this is what we are looking over in this particular lecture. That is artificial intelligence and machine learning. At the year 2018 to 2020, by this time, this technology, that is artificial intelligence and machine learning, should be mature. Means already this platform should be mature and it should be placed in the industries, and certain fruits of this technology is already we need to enjoy by the end of 2020. That is the meaning. Therefore, nowadays you can see everyone is, is looking for even AICTE, DST projects, or even different agencies. They are looking over, or they are emphasizing on these kind of aspects, artificial intelligence and machine learning. And in the future, you can see something called additive manufacturing by the year 2020. And by 2025, actually, we are looking for grid scale batteries, store excess energy during day for using day night, right? So these kind of things are after the artificial intelligence and machine learning, I think researchers will look over. In perspective of India, the researchers are look over morely on this kind of technologies, that is called additive manufacturing, grid scale batteries, because they already frozen that time scale, the 2020 and 2025. And one interesting thing that is called impact felt already, that is in the left hand side. That means the crowdsourcing or the sharing economy and peer-to-peer platforms, already we are seeing their maturity levels already reached, and we are already feeling the impact of that in our platforms. So therefore, the impact is already felt about this technology. It was now matured at this stage. Therefore, our concentration here is on, with respect to 2020, it is artificial intelligence and machine learning. We are, again, I can say, at the right platform. So why this machine learning? Fine. We said that machine learning, artificial intelligence, machine learning is important. That's fine. Obviously, it is important. And according to policies of India, yes, it is required for us. And according to global standards, yes, we are into in a correct line. So why this machine learning is so much of important? The MS indicates is a manufacturing systems, and SCM indicates it's called supply chain management. Because machine learning, because these manufacturing systems, I said you the current manufacturing systems according to Industry 4.0, several characteristics, several functionalities, several properties, and we need to be taken care. Therefore, data, and not only that, the capabilities of delivering the product in timely is also one of the important factor nowadays. You have to fulfill the customer within a time. If the Swiggy person won't deliver your food in a proper time, you know what is that impact. You can for that, for example, Domino's, for example, any other platforms, they have to serve within the time limits, otherwise they pay the penalty. That you know very well. Therefore, imagine I'm talking about a small food, and when we talk about a big things, big products, big customers, timely delivery is much essential here. And due to this mammoth data, unwanted information is, it's flowing like a river. So catching of this unwanted information and executing of the real information is a real challenge nowadays, because a sensor can create one sensor instrument can can produce a lot of data. From that data, retrieving of the exact data what we are looking for is a crucial aspect. Of course, one of the application, real life application, is there in the next slides with respect to the supply chain management context. There I will show you how the sensors retrieve the information, and from that information how we have done the cleaning, all that. There you will understand very clearly about this unwanted information and the big data. And the superior technologies like blockchain, technologies like IIoT, AI, all these superior technologies is need to be imbibed in this MS and SCM. While you are doing that, a sophisticated algorithms, a powerful algorithms can only do the task. Therefore, machine learning. That is the need of machine learning nowadays. That is why we are concentrating a lot on machine learning for solving the problems of today's context, that is called MS and SCM. And not only that, I said you there is something else is coming up, that is called recent technologies adoption in various organizations. Well, it is not only the technologies, it is also something else. It is imbibing across it. For example, if you see a ship at the right hand side, a physical ship, a natural ship, and it is taking a loads of containers. And when it is the other side, you can see the digital twin of the same product, the fleet. The replica of the digital twin actually help, you know actually help this particular ship. When this particular ship is moving, at what time it is moving, how much load it is carrying, and could it carry the right amount of load. All this information, when any disaster happen inside a particular, in any one of the container, how it could be monitored. All this information can be gathered with the help of the digital twins. So that is one of the beauty. So these are the recent technologies nowadays. For example, it's not only the fleet management. For example, let's see the left hand side, the power plant is also, the entire power plant can be monitored with the replica of the power plant, that is called the simulation of the power plant, that is called digital twins. So where exact amount, how much carbon emissions are emitting, at what stage you are, which kind of boiler you want to maintain, and what device you have to taken care of, all this can be done. It is not a simple task, right? So therefore, to taken care of this kind of recent technologies in various organizations, you require certain thing called a machine learning, right? And what you can see out of this slide, all together, I brought something called zebra herd here, or something called ostriches, which are moving with the zebra lines. Can anybody say something about this? What you have understood from this? Are you with me? Can you hear my voice?
Yes, sir. It is clear. Voice is clear, sir.
Yeah, great. Okay. So, like you see, in not only the industry 4.0, I must say uh, there is something else also we need to concentrate on. That is called the third wave of uh, it's called the third wave of revolution. What is the third wave? Yes, we see already first waves and second waves. The first wave from the crafting stage and the automation stage. But in the third stage, some researchers has brought that it's a controversy story of the industry 4.0. The controversy story or the other side of the coin is it's a man in the middle. The man in the middle, like for example, if you see this zebra herd and the ostriches, the zebras are not good with something called their eyesight. Their eyesight is not proper. They cannot find the predators very quickly. But whereas the ostriches, they can see the things uh, from where their sensing abilities, their seeing abilities are superb compared to the zebra herdings. So what I'm saying here is, you know, therefore these two zebra herd and the ostriches move together every time uh, to protect themselves from the predators. They are mutually complement each other. So whereas the sensing capability is not good with the other one, some other things are having the sensing capability. Some are good with sensing and some are not good with sensing. So these two, what they are doing is they're complementing each other to do the any task. So this kind of nature actually bringing back to the industries. So therefore, nowadays a new kind of technology or new kind of word is buzzing, that is called intelligent manufacturing systems or the intelligent enterprises. What these intelligent enterprises do is, these enterprises is designed to take advantage of the complementary nature and the symbiosis of man and the machine. Yeah. Hello. Yeah. Can you hear me?
Yes, sir. Voice is clear, sir.
Yeah.
Clear.
Fine. Fine. Okay. So the symbiosis nature is actually looking to adopt in the recent industries nowadays. The symbiosis nature is like, the man, if you give a task to the man, the repeated task is some point of time he will be very bored. Therefore human being is very good with the ideas, very good with their thoughts, very good with their intelligence. So let the man do their man business. Let the human being should be a human being, or the machine should be a machine. What the machine do in the other side is, the machine do the repeated tasks every time. They won't bore. They are fine with that. So let the machines do the machine business and man do the man business. This complementary nature of the man and the machine will really do a wonderful wonders in the intelligent enterprises. That is why we are nowadays calling it as man in the middle, and that is going to come in the near future, that we are calling it as a third wave, right? So these kind of enterprises may you will see in the near futures. So why this is so much of essential? Why I'm talking this one? Either any limitations in the industry 4.0 or any limitations in the automation? Yeah, yes. With strong opinion, I can say yes, there are limitations. Let us see that. You must be heard this kind of or heard or see in the news recently about the Tesla car story. So there in the left hand side, the picture shows it's in one of the show. The Chinese women is standing. Is actually she's protesting by standing on the Tesla car. You know what is the Tesla car? The Tesla car is a US product. It is a automated car driverless car, it do certain things with driver. So actually when I talk about these, there is a misconceptions of everyone. Automation means a driverless car means it do all the tasks, whether the Tesla car is doing all the tasks. Have you heard about the recent story, the recent 6 months back? uh, what happened to the Tesla cars? 25 to 30 Tesla cars, uh, without starting, without starting, they unlock their automated device and they travel by their own, and that too, they crash in somewhere, and around 30 to 40 cars was destroyed, and it was created lot of havoc in different countries. That is why she is protesting over there. So therefore, yes, there were limitations. When the snow falls, the man in the Tesla car need to be controlled. When the sudden brake need to be done, yes, the man in the middle need to be taken care of these automated devices. There were certain limitations in the automation. And in the right hand side, I have taken this source from the Wipro about the Win automation, a beautiful framework you might be seeing here. Like, for example, let us see from the supplier side. Supplier is great, is using Industry 4.0 logistics, fantastic. And then it comes to the manufacturing units. In the manufacturing unit, smart manufacturing, they were using smart sensors, factory automation, intelligent material handling, robotic automation, fantastic. They are using all the things about Industry 4.0. And then they're using even advanced manufacturing systems to analyze the data, gather the data by using the cloud computing and doing the big data analytics. Of course, they are taking care of the cyber security. Fine, well done. And these products are giving back to the products, and the products are smart factories. In fact, smart products of because of dashboard you can see over here. So IoT and warehouses are automated, and ultimately it is reaching to the customers. Can anybody see any limitation in this wonderful framework? I see a small limitations. For example, while doing this business, let us assume a small interruption in the internet. A small interruption in the internet, or for example, in the smart manufacturing, while you are connecting sensors onto this factory, and this the your signals are your internet signal, suppose it is weak. Assume this kind of limitation. When your internet signals are weak, the sensors won't work 100% efficient. So there may be a chance that some of the information you may be lose because of interface between the sensors data as well as your devices. If you lose, for example, you lose small amount of informations, really that works in the smart manufacturing organization? I don't think so. That small information is also very essential here. So therefore, nowadays you might be seeing something called edge computing, grid computing. So these are the wonderful things which are actually overcoming the limitations of the cloud computing, and it can do the task of these limitations, that is called weak signals in the internet, or something like internet is not working properly, or something other limitations are there. Because I want to go the deeper side of the machine learning now, so that I'm stopping at this point. So these limitations are need to be taken care, and therefore there are these are the some of the misconceptions that automation, if you are automation, everything can be done by automation. No, it is not the hard truth. Therefore, emphasis on the man in the middle will definitely will be there, and the future will be the intelligent manufacturing and enterprises. That means the symbiosis of man machine will come, and lot of business may happen, lot of jobs may come out. And I will show you some important job profiles nowadays the organizations are looking for. Therefore, our academic programs need to be transferred. Okay, that is the other part. So now Let us dive towards the machine learning. No, the machine learning is under the umbrella of artificial intelligence. Yes, it is one of the part. So artificial intelligence broadly taking care of the computers with the ability to reason as humans. Whatever I gave as a for example, I am doing some certain task. The task I programmed in the computer, if the task is exactly programmed, and if the computer is exactly behaving, or the resources are exactly behaving whatever coded, that is a part of the artificial intelligence. Let us see the machine learning here. Machine learning do you know in addition of this artificial intelligence. That means the computers not only do whatever I will give as a program. At some point of time, this computer program, this computer is having the, or the programming is having the ability to understand what I am giving. They will learn it. In future, if I want to apply that task, automatically with the help of the machine learning algorithms, the computer do the task with less stress on the human being. So that is what machine learning is. Therefore, the machine learning, it allows the system to learn new things from the data. Actually, it involves in creating self-learning algorithms. Machine learning is basically, it leads towards the knowledge, whereas the artificial intelligence, it leads towards the intelligence or wisdom. No. So let us talk something about the other side. If you go the deeper side of the machine learning, you are learning something called deep learning technologies. So what here again, some reinforcement learning, all the technologies may come. That is a future story. But let us concentrate on the machine learning at this point. I said machine learning. It's all about aims to increase the accuracy. It does not care about the success. It leads to knowledge. It involves in creating self-learning algorithms, and it also learn things from the data, etc. Right? So, while doing it, therefore, Arthur Samuel at 1958, he said, it is the field of study that gives computers the ability to learn without being explicitly programmed. That what we are doing in the AI, artificial intelligence. If you ask me broadly, it is the machine learning is basically divided into three different kinds of the learning platforms. One is called supervised learning, other one is unsupervised learning, the third one is called reinforcement learning. uh, I will discuss in detail about the supervised and unsupervised learning, but let me talk about reinforcement learning with an example here. So what the reinforcement learning is, for example, uh, let me put you in a something called in uh, in one island. In island, if I want to keep you and nobody is there in that island, and maybe in one day you struggle it, you are not, you are somewhat discomfort to understand the environment, to adopt the environment. After 1 week of time, automatically what you do is, if nobody is there, you yourself will adopt according to the environment, and you will learn how to cook, and you will learn how to live. You know that who teach that? Nobody teach you. Nobody was there. You yourself learned it. So therefore, the reinforcement is exactly that only. It learns from the mistakes. It will do mistakes, and then it will identify this is a mistake, and it should not do the mistake again. In that way, it will correct it back. Therefore, after you feeding the algorithms, it learn from the data, it do mistakes. From the mistakes, it will learn, and it correct it, and it will give the correct solutions. That is what reinforcement learning is. I am not touching the deeper side of the reinforcement learning. Let us concentrate on the two factors. One is called supervised learning and the unsupervised learning. You often heard about these particular words every time, right? So let us see what is called supervised and the unsupervised learning. If you supervised learning, if I want to talk about two kinds of data. The data could be a continuous and data could be a discrete. When the data is discrete, you can use the classification or categorization. You know what is called classification? The classification means man and women. There are two classifications, right? So if you want to classify the data in this way, suppose you have a data, you want to classify into two types, the man and women, 1 or 0, etc., etc., yes or no. This is called classification. So want to classify the discrete data, then you can use the supervised learning techniques. And of course, for example, you have a discrete data, but you want to cluster it, then you can use unsupervised learning technique. You want to cluster. What is the meaning of cluster is, in the same way, for example, I said you man and women. So in the man and women, if I want to categorize years from 0 to 10 and 10 to 20, 20 to 30, 20 to 40, and 40 to 40 to 60, and 60 to 80 into different groups, then it is called a cluster. So if I want to cluster the data from the discrete data, then I can use unsupervised learning techniques. And for example, your data is continuous, then you will use, for the classification, you will use a regression analysis for the from the supervised learning, and whereas for dimensionality reduction, you will use unsupervised learning techniques. Again, why I have given this kind of table is because till today we used to, while we are reviewing many articles, you know, the researchers often use the wrong statements while they are using this supervised and the unsupervised learning kind of techniques with respect to continuous and the discrete in nature. The same thing what I said, I categorized into this way: the clusters, then you can use unsupervised, whereas for the classification you will use a supervised line of techniques. Right? And the same thing I will give in a pictorial representation. The supervised learning, let us see. I said you classification, right? A duck, and you have rabbit and kind of animal. In these, what supervised learning algorithm will do is, according to the supervised learning, I said you that it is a classification problem. It basically divides. According to the classification, what it will predict is, among all these, duck, duck, and not duck, it will predict, for example, after giving this one, yes, it is duck, means yes, it is a duck. If it is a rabbit, it will tell it is a rabbit. It is some animal, that name it will exactly predict it. Whereas in the unsupervised learning, you can see there are 1, 2, 3 different types of ducks are there in this data. So it won't tell individual duck. All the ducks together, irrespective of their breed, it will take all these ducks together and it will classify as one classification. These are ducks. Rabbit, there is only one rabbit, therefore another classification it has done, that is called rabbit. And altogether there is another animal, it is called another. Therefore we got it here 3 different kinds of clusters. This is called clustering, and this is, therefore it is called classification. I hope you understand now what is called classification and clustering, and when to use, for what kind of data, what algorithms should be used. So here in this particular slide, I have given, depending upon the data, depending upon the problem you have solved, people often confuse which algorithm I should use, because in the machine learning you may be having classifications, you may be having clusters, at what point of time which one should be used, it's all together a confusing task. This particular slide I have taken from the Microsoft Azure poster, and that particular team has beautifully created this kind of slide. At what point of time which algorithm could be useful? For example, let us see something called regression. You know, all most of you know what is called regression, but in regression also there are many regression analyses are there. Ordinal regression is there, Poisson regression, fast forward, linear, Bayesian, neural network regression analysis also there, decision forest regression. There are varieties of regression analysis are there. I see this kind of I see number of students while they are while they are doing their projects on neural networks particularly. Inside the MATLAB toolbox, you can see regressions, randomly selecting of some regression and predicting the data and identifying the results. Yeah, yeah. Can you hear me?
Sir, voice is clear, please.
Yeah. Can I continue?
Yes.
Yeah. Oh. So what happens is often confuse what kind of technique exactly should be used on what kind of model. So therefore, here we used a certain thing called for example, you want to data is rank ordered categorizations. Then you use ordinal regression. For example, you have a long training time and you need accuracy. Use neural network regression. For example, you require certain analysis like small data sets and you have a linear model, then use Bayesian linear regression analysis. So like these, you know, depending upon the data, depending upon what is your outcome, you have to use the regression analysis accordingly, right? So similarly, there are many other things like, for example, clustering. We know that there is k-means clustering, c-means clustering, fuzzy k-means, fuzzy c-means, SVM, SVR, PCA, etc. There are several clustering techniques are available. But at what time you have to use it? For example, if your features is more than 100 and your model is linear, then use two class SVM approach. If you use, you can use other one also, but if you use the two class support vector machine, what happens? It will give the optimal results. In this way, the machine learning algorithms will help you to solve the problems depending upon your data, depending upon your problem nature. So here in this slide, I have shown you some of the machine learning applications, like automation, cars, face recognitions, and nowadays in home, everyone is is talking about Netflix, Amazon. These are the platforms. So if you see a movie and automatically the next within a few hours you will get recommended movies on your name. How those recommended names on particular of your name, how it is categorizing. It's actually the recommended algorithms inside of this Netflix. It is actually taking care of it. Similarly to the Amazon, similarly to the other digital platforms. And here the other very interesting example I would like to give. You can see some of the tomatoes here. It's a tomato tree, consists of varieties of tomatoes with different colors. With the machine learning algorithm, actually you can see inside some of the percentages also, at whether the fruit is ripened for 100%, whether the fruit is ripened at what percentage it has ripened, how many chemicals they have used in this particular tomato, whether they are danger or whether it can be eatable, at what time you have to pluck this particular tomato, all this information, what is the texture color, all this information can be available with the help of machine learning, where it is impossible in a human being interference, right? So beautiful examples and beautiful applications are there. These are some of the applications I have given at this point. So up to here, I have given some glimpse about what is called machine learning categories, machine learning algorithms, and when it has to use, at what time it has to use, at what kind of data, and some of the applications. And now I would like to give some of the real life examples what we have conducted with respect to the machine learning. And here I would like to give example on the supply chain management, particular to, it's a fleet management in a mining industry. Can I take 1 minute break, and then can we continue these use cases?
Yes, sir, definitely. We can wait for.
Yeah.
Okay,
Just
sir.
just give me a minute so that I will come
Yeah,
back
yeah.
again and I will take.
Yeah, yeah, definitely, sir.
Thank you.
Participants are requested to write their queries, if any, in the chat box. I will come back within a minute.
Yeah. I'm here.
Okay, sir.
Let me first give the applications, and then I see if, yeah, can you hear me?
Yes, sir.
Yeah. I see some of the questions in the chat box. I will
Mhm.
detail those answers for those questions very clearly after the lecture. I think I will take
Okay,
some
okay.
time. Definitely, I
Yeah,
will
yeah.
give explanation for each and every question.
Okay, sir.
Yeah. So now you can see me, sir. See my screen.
Yeah, yeah, definitely, sir.
Yeah. This is the application what we have conducted as a fleet management in a mining industry. So here we have used IoT devices, and we used an integration with the machine learning and soft computing techniques. That is the platform. Let me clear what is this problem description is first. First, what is the importance of this code? Because we conducted this particular fleet management in a mining industry. With the initiation of the Pradhan Mantri Sahaj Bijli Har Ghar Yojana, we used to call it a Saubhagya. The rise in the demand of the coal has increased now. The coal demand in India would reach in the future, 748 million tons in the calendar year 2024, making it the world's fastest growing coal consumer in absolute terms, because we have reserves. We have huge reserves of coal. Therefore, the Indian Energy Agency forecast, they have given this forecasting one, that is by 2024 we reach 748 million tons of coal demand. Not only that, the driving force for India heading towards being a metallurgical coal growth mechanism is the scarcity of high quality coal for steel production. This also we need to be taken care of, right? So therefore, um, digging of the coal, utilization of the coal, yes, fine. But our concentration in this particular coal mine is the waste management. Because when before you are digging on the coal, upside of the layer, you might see a lot of sand on it, a lot of soil on it. You know, this is equally a cumbersome process in the coal industry. First, if you want to dig a coal, you want to dig the soil on the upper layer, and you have to dump all the soil into a certain place. It is equally a cumbersome and complex process. So therefore, before taking out the coal, the soil covering up the coal is to be digged out. The soil is nothing but a mine waste. This kind of thing we used to call it as a mine waste. And the mine waste is equally important. Even some of the industries are looking for this mine waste, as it is of no use and it taken for dumping ground. But from the dumping ground, yes, many industries will take this particular soil. That is the other part. So this waste need to be removed. After taking out the soil, covering up the coal, the actual resource of our needs comes up. That you know very well. That soil is taken to the dumping ground, which is a place in the mine from where the coal is taken out. This is the entire problem description actually. Looks simple, right? But it is not simple, because to build an effective monitoring system to keep an eye on the mine fleet, that is one of our objective. To develop a model of dispatching truck in the real time, loading time of the shovel decreases, and the ideal time of the each excavator or the shovel, limit the waiting time of the truck to increase the productivity of the source. These all are equally important. These are complex. It's not a simple problem, because they are doing all these in a traditional manner. We don't know when the truck will go, at what point of time truck will go, at what amount of sand it is taking out. There is no clear indication of all these systems. Therefore, we require a clear cut monitoring system for doing this. Therefore, we started from the scratch. So that is, these are the different activities happen in the mine. One is waiting of the truck and the excavator. Near the excavator, the truck will wait. When after that, with the help of the excavator, the truck will be loaded. That is, the sand or the soil is loaded, and the truck travel with a load. It goes across the mine. Mine is not a small distance. It occupies huge space. It has to cover huge land of kilometers of the land, and then it goes to the dumping yard and it unload it. This is what the different activities happen in the mine. But after that, the truck will come empty, and the truck will come empty, and it has to reach to the waiting. Sometimes traveling with a load, it goes to stop with a load at one point of time where the maintenance will happen at that place. Maybe some screws will be tightened up, and some tires may be loaded, and the driver shift maybe happens. As I said, this because the traveling with load, the traveling time is too high, and the coal area is not a small distance. It need to cover a huge distance. Therefore, it stops with load at one point of time. Otherwise, the travel empty truck will go back to the waiting area. The traveling empty, again, it will stop the empty truck at some distance, at some place. From there, the again driver, other driver will come and it will do the same business. It will go as a waiting area, and then the remaining task will be happen. So these are the different things happen in the different activities of the mind. Actually, uh, we have find it out. These are the things happen before that. So there is no such monitoring system at all. Where is this loading? Where it is emptying? Where they are stopping? No idea at all. So the challenges in front of is there is no communication at all. There is no monitoring system at all. The mine is very ineffectively handling, and therefore lot of wastage in time. So these are the challenges in front of us. So what we need to do for this? What we have done is we have developed an IoT devices, and these IoT devices we kept on the truck, on the excavator. So on the truck, the IoT devices, what it do is how many kilometers the truck has covered, at what distance it has covered, what is the fuel, how many carbon emissions it is emitting, because we also need to take care about the sustainability factors. So what is the driver shift? That all things, everything will be taken care of by these IoT devices. And at the excavator side, how much it is digging, what amount it is digging, and at what point of the distance between the truck and the excavator, because at this excavator, uh, when the other truck will come, it should wait. Then there will be a lot of chaos. Therefore, these IoT devices and these another IoT devices on the truck will have a RFID, so that they can be taken care of at how much distance it is, so that immediately the other truck which is loading can be complete and it can be sent it out. Therefore, no interruption between the two trucks. That also we have taken care here. So therefore, we adopted, installed a wireless media. Now the data transfer is taken place, and from the excavator through this wireless media, again the monitoring system will be taken, data transfer is taking place, and with this information we generated this kind of string. The sensors will give a different kinds of information. The inks, that is black, red, blue, green, all these different colors and different numbers you are seeing, there are these information actually we got from these IoT devices given by different sensors. There is a sensor which can take care of date and time. There is a sensor which can take care of the RFID. There is a sensor which can take care of the latitude and altitude and longitude. There are the sensors which can taken care of the speed of the truck, etc. And this information has provided. Retrieving the information and understanding of this information is a challenge actually. This we have taken 3 months of time we have taken only to understand this data, because this is not a single string data. It is millions of such data will be get it out, and that need to be decoded. For example, you are just understanding this 70, but it is not exactly 70. It is 8-bit binary code. It talks about, it could be like this, where one indicates yes truck, dispatching, empty, where is that location, etc., etc. All this information. That much of complexity is there in this data stream. Fine. After that, our concentration is on developing of a mathematical model. For that, we define such an variables S, H, I, D, A, etc. for speed, hoist, ignition, distance between tipper and excavator, and the output parameters. What we are noticing is stop empty, where it is loading, where it is unloading, what is the traveling empty, when it is traveling empty, what is the waiting speed, where it is stopped with the load, etc. So therefore, we developed a mathematical model. Now, this is the fleet management approach: loading and unloading. Now we are able to take the real-time decision making between these two. Previously, no such. Because of these IoT devices, because of this information, we could able to achieve a real-time decision making. That means which truck need to be sent, what truck is at what place, which excavator is digging, which excavator is busy, which excavator person handling the excavator is changing their shifts. All these things can be taken place. So therefore, we also require what is the excavator specifications, tipper specifications, all this because of calculating the fuel, manpower, flow rate, all that. So these are the different things, key performance indicators, because we calculated something called total waiting time of the tippers, total production time of the sources, and the loading time of the excavator, etc. This is what we have calculated. So ultimately, we identified results, and for doing this, what we have done is we have used machine learning model. There is regression analysis, and whereas we find out the R square value is zero point 0.9 at this point of time, and that is giving a significant results. For example, if you see, uh, this is the red ink indicates it is the proposed model. For example, let us see 4,500 is the total production. For that, they used around 36 trucks. They have used for digging out of the total production 4,500 tons. With the same 36 trucks, with our proposed model, we could able to achieve 5,293 tons of total production. There you can see the significant difference between these two. In the supply chain management, you can heard very clearly about coordination uncoordination problem, where the beer game you might be heard about it. These IoT devices, all these is nothing but it's collaboration and uncollaboration models. So the a simple concept: loading of the sensors, making the devices intelligent, monitoring of the data, retrieving of the data, applying of the machine learning algorithms will give us a significant difference, and it can improve the production in a greater way in this kind of fleet management concept. We have used this one in one of the our country problem only. Later we have used this proposed model for different mines in the Telangana state also, and we have achieved a significant results. So, and we improved the fleet management of waste management of in the fleet of coal mine. So this is about one such application with respect to the coal industry. Now I would like to take you to the other case study. This was recently accepted for the publication in the CRRP Annals Manufacturing Technology. So one of the prestigious journal in the area of the manufacturing systems. And here, some of with my collaborators, we have done this work. And this is a real life industry problem. This industry is situated in the Portugal, and this industry is from way back 1856 onwards. This industry is working, and moreover, this industry do they develop small, medium, heavy, and highly heavy machines and the products, right? So for that, these are the manufacturing units they are having, and this is one such industry setup for that industry. They are having two groups of machines. One group of machine is like this we have given, and another group of machines. Why this particular model is so much of important, and it is almost so very essential for today's is everyone is talking about industry 4.0. You need IoT, you need IIoT, you need cyber physical systems, right? But really these industries, all the real life industries will adopt this industry 4.0 concepts. If not, or if yes, for example, uh, tomorrow some other technologies may come that is called industry 5.0. They are altogether come up with the different technologies. For example, assume that industry 7.0 is coming up in the near future with altogether new technologies. Are the industries are really ready to adopt all these new technologies again to make it very effective? I don't think so. Industries won't adopt all the new technologies immediately because it is a cost affair. No. So therefore, we in this problem we are planning to say that no, you need not to adopt all that because it is a cost affair. That is the interesting thing about this problem. And the objective of this problem is regarding the maintenance of these particular machines. When you need to do the maintenance in ordinary machine, in ordinary any unit, any organization, if you go, the maintenance manager may come for one day in some point of time, and he will monitor each and every system or any machine, and if any lubrication this and that we require that they used to do, and in that way the maintenance manager will be taking care of. So that is about the ordinary thing. When you have a cyber physical systems, when you want to convert the units into intelligent machines, then how to do it? Of course, that is another challenge. But here we are not exactly maintaining at a cyber physical systems. What we are doing is, let me show you. This is group 1 and group 2. There are different machines are there. This is a group of machines and these are group of machines. First strategy is combined mission. The meaning of the first strategy here is, all the machines together in the unit, we are together calling it as a machine system, and maintenance may happen in one point of time. That means the maintenance manager may come, he will check all the machines at once, thinking that all the machines as doing a single task, and the certain maintenance will be happen. The second strategy is multiple machines. Here, in the entire shop floor, he is categorizing the machines into different machines, different groups. That is what the groups are, group 1 and group 2. Previously there are no groups, all together machines, and we are grouped into group 1 and group 2. And now these multiple machines, they do this maintenance for the group 1 in one point of time and group 2 in another point of time. In that way the maintenance manager will be taking care of it. The next third strategy, the individual machine level maintenance. That means each and every machine is taken care of. Imagine in your industry, if you are having 250 machines, each and every machine maintenance by the maintenance manager, it is really a achievable task. First of all, impossible. That is almost an impossible task, but you need to do because you need effective solutions. So we propose a model here, that is this. Really the machine intelligence, machine learning will help us to do this task. What we have done is, for all the machines together, that is for the combined strategy number 1, we thought all the machines are call it as one. So therefore we learn different machine learning algorithms while they are processing. I am not talking about how to take the data, how to process it, how to control. I'm not going the deeper side. Let me tell you, fine, to find out our effectiveness and the efficiency, to improve the process and for improve the maintenance, what we have done is different algorithms in the machine learning. As I said, SVM, RF with 1K learners. Out of hundreds of different kinds of machine learning algorithms, we identified certain machine algorithms are performing above 80% of the efficiency. That 80% above efficiency algorithms only we have taken, and again we have monitored with these algorithms about the combined machine strategy. Then you can see the percentages here. With the combined machines, these are the different accuracy we got. Simply we can say out of this one, SVM cubic is best strategy, right? You will agree, I will agree, because here R square is also, F1 score is 0.977, fine. But whether this is sufficient? No, because in the multiple machines strategy, group 1 and group 2, according to that, after we learn the machine learning, the SVM cubic again it is performed better. Fine. With the SVM cubic, can we go ahead and say that yes, we will apply the machine learning algorithm called SV cubic, and according to this algorithm, we will find out when exactly the machine needs the maintenance and at what point of time it needs the maintenance. Then the maintenance manager will come and he will do and he will monitor the machines. That is the other part. Now, our model here is what we have done is we have considered each and every machine as an individual machine. Previously, it was not like that. When you do that, what happens is it is not a 1 month data, it is not a 1 day, 1 week, or 1 month data. The data we have taken is 3 months data, and then we have taken 4 months of data, and we have taken 5 months of data. And imagine 3 months of data means millions and millions of data. So this data we have taken, and what we have done is each algorithm for each machine, for example, machine number 18, M18. For this, we run all the 100 algorithms, and out of all the algorithms, we identified that SV cubic is best for machine number 18. And for the machine number 19, SVM quadratic with high box constraint level is best. Like that, for each individual missions, we identified which algorithm is better. So that what we can understand is, for example, 18th machine, with the help of SVM cubic, because it is highly efficient, it will tell this particular machine require the maintenance of so and so machine 18 at this much of time and this much of at this date, at this time, this maintenance manager should come and he should repair my machine. It all generate automatically. So there is no requirement of any inference, any cyber physical systems, any IoT devices. We are feeding the machine with the intelligence. The intelligence will be taking care of it, rather than loading of the sensors, because that industry is having 280 different kinds of machines, and loading of sensors on each and every machine, it's a very cost-effective business. Therefore, this is the challenge in front of us. And now, with the help of these machine learning algorithms, with the help of these machine learning techniques, we could able to manage which machine is performing at what point of time exactly. That is the beauty of this one. So therefore, future any technology may come, we are okay with this, because the percentages, if you see the F1 score, it is above 85% and sometimes 75%. It is quite sufficient for the real life industries, right? So that is about this particular case study. It's about manufacturing systems case study. And I would like to take one more case study and then I will wind up. This is a distributed sir, is it okay? Can I go ahead with another case study?
Yeah, please, sir, please.
Yeah. The other kind of manufacturing platforms. In fact, nowadays, every manufacturing platform is a distributed in nature, because a lot of business may happen, a lot of profits may achieve. The large scale enterprises kind of concept has it's dropped by many industries after this industry 4.0. Therefore, a new kind of manufacturing system is come up. It's called distributed manufacturing system rather than the centralized manufacturing systems. So therefore, in this, generally, if the customers will come up with any product, and generally the enterprise user and the customer user will be taking place. The enterprise user indicates that they are having certain industries with them, and the remaining to produce the product. In addition of that, any products need to produce, they will give to the subcontracting. Like for example, Cummins, L&T, they have their own manufacturing units, and if they could not able to produce certain products, they will give for the subcontracting. The other side is called user. That means, Infosys, all these MNCs, they cannot produce the product. They don't have the manufacturing units, but how they are producing? how they are producing 150 varieties of products under their name. Actually, it is going for the subcontracting, and then it comes back to the user, that is called the MNCs, and the products is producing in that way. You know, while doing this subcontracting, etc., it undergoes in a cloud environment. It could be a network manufacturing, supply chain management, enterprises, healthcare, business, mining, etc. Whatever it might be, it will undergo, you know, because they are geographically distributed, all these different enterprises, they collaboratively how to do the business. Therefore, ICT, information and communication technology, is the only source to collaborate among themselves and to achieve the task, and it will give back to the enterprise user and the supplier user, ultimately going the product to the customer. While doing this, there are of course certain analysis you have to do. You have to do the remote solution services. It could be a simulation, optimization, all that, right? So this is the broad domain of the distributed manufacturing platform. Exactly, in the cloud manufacturing, in the distributed manufacturing enterprises, the distributed enterprises will gather the information, and that data will go back to the optimization and simulation services, right? Here we would like to do this particular task in a different way. When you are quoting about this inside the cloud, you can see different enterprises, right? Maybe assume that this enterprise and this enterprise are doing the same kind of product, same kind of operation. To whom I should select? Therefore, there are challenges. I'm talking only two. For example, these 10 enterprises are doing the same task, and this particular enterprise user select to whom he will select among these 10. Maybe the nearer person. If this enterprise is in Chennai, in Tamil Nadu, whether he will select the near Tamil Nadu place, or he will select the most potential enterprise, or whether he will select the person who is entirely unknown, who can deliver the product with very rapid speed. So there are these challenges need to be taken care. That will be considered here as one of the problem. Here in the machine learning, we applied these problems with respect to machine learning. If you carefully see here, yes, initially the product is coming from the suppliers. There could be in India, there could be many suppliers. We don't know who are the manufacturing suppliers, who are the non-manufacturing suppliers. So if you just type it in the Google, you will get a lot of companies. Out of that companies, you need to segregate who is the manufacturing supplier, who is the non-manufacturing supplier. Depending upon my data availability, I run the classification with the text mining approach, that is classification approach, and my algorithm will has divided it into classification, that is called manufacturing suppliers and non-manufacturing suppliers. Among these two, my concentration is only on the manufacturing suppliers, because my product, this customer user, he may be looking for some automobile product, assume. So in the manufacturing suppliers, again, for the specific product, which manufacturing suppliers are doing it. That is called product specific suppliers. Therefore, I applied a clustering technique and identified it this way. And then with the help of that clustering algorithm, I divided the number of suppliers and their task, etc. When I am doing this, I got an output like this. In the right hand side, you might see. That is, so and so supplier, so and so manufacturing supplier, so and so specific manufacturing supplier is doing this kind of thing. He might be doing the services like casting, and he also can do milling, aluminum, machining, manufacturer. Okay, with the help of this test mining approach, I can easily identify what this particular supplier is doing, rather reading off all the data in their website. Just I got all the information from the website. I run the algorithm. I got this kind of text mining kind of text. With the help of the text, I can easily identify so and so industry, so and so supplier do the so and so task, so that I can assign according to my wish. So therefore, machine learning actually helps the manufacturing enterprises to select who is the best supplier and what, and by doing this, lot of time can be reduced, lot of efficiency can be improved. So these all things can be achieved by the in a decentralized manufacturing environment. So whatever I have given here as an application, those are the published works, and you can find these all things from my references. So with this, I would like to stop at this point, and I would like to take the queries from your side now. Thank you so much.
Thanks, sir. The session was very informative. Few queries are here from Raveen. The question is supervised learning more accurate than unsupervised? Is supervised learning is more accurate than unsupervised? And some information regarding its accuracy.
No, let me from Raveen. From
Yes,
Raveen,
sir.
this question is Raveen. I
Yes.
would like to say that supervised learning technique is different approach, and unsupervised learning technique is a different approach. I also mentioned in this slide. Let me go back to my slide. I will show you here in the supervised learning. Yeah, yeah. You can see here in the supervised learning what you are doing. In the supervised learning, you are classifying. That means category A or category B. To do this kind of analysis from your data, you can use the supervised learning. Or if you want to categorize into groups, that is called clustering, you can use the unsupervised learning. These are the two different approaches for the machine learning. So for the supervised learning, there are different algorithms exist. For the unsupervised learning, there are different kinds of algorithms exist. And also in the next slide, I have given when to use for what data at what point of time, which algorithm should be used. That also I have clearly given that you can identify. I hope I have given you an answer for this.
Yeah, definitely, sir. Next question is from Chetam H. Sai Baba. That is the how can we use IIoT in waste management area? I think sir has explained the case study. Even then,
Yeah. See, in the waste management area, I think I have given one application also with respect to the supply chain management. You can use different sensors. It depends upon the context of your problem. For example, food waste is a different area, and health waste, it's a different area. Recently, I think we have done one work on COVID-19 in CMC hospital, uh, where we identified that they are after doing the treatment, the syringes they are just dumping the outside. While they are dumping outside, there are different applications, different approaches they use for dumping this health waste. It's a very cumbersome process, you know. So there, certain technologies can be used like IIoT and IoT devices, so that it will monitor how much waste has been dumped, at what point of time it has dumped, and whether the wastages what you have burned out is really burned out, how much carbon emissions it has emitted, at what distance it has emitted. All these things can be taken care. I just gave you one healthcare example. It depends upon the problem that what kind of sensors you have integrated with your area. So that is what I can say, Sai Baba.
thank you, sir. So now that is the time for the formal vote of thanks on behalf of the FDP team and entire SKT fraternity. I extend my sincere thanks to our esteemed speaker of this session, Dr. Vijay Kumar, Faculty Department of Mechanical Engineering, NIT Warangal, sparing his busy schedule to grace this session. So today we had an opportunity to hear your expertise in the field of machine learning and artificial intelligence. And we are very grateful to you for explaining various aspects of, we can say, that is the advanced emerging manufacturing technologies, predictive analysis, smart factories, IoT, and mainly the concept of machine learning, supervised learning, unsupervised learning, and reinforcement learning. So better examples were quoted by you, and sir explained the different concept of recent technology adoption by the various organizations. Like machine limitations were explained by the examples of we can say Indian Airlines, Tesla company, and Wipro company. And case study of mining industry or waste management were explained with IoT perspective. The other case study was taken for the optimization by using the different strategy for machine maintenance, and the other case study was also taken for the supply chain management. So these cases they were explained very nicely. So these were the very better example to understand the things. So the session was very knowledgeable and informative, sir, for the participants, and it will motivate the participants for the research work and the different conceptual work for in their field. So I extend my sincere thanks, sir, and thanks to participants for joining this session. Now, may I request all the panelist members to put on their cameras for a session photograph. Sir, please.
Thank you, Dr. Deepak Kumar, for nice words, and it's my
Thank you, sir.
pleasure that to be with your team. Thank you so much for the opportunity.
Thank you, sir.
Thank you, Manan sir. Thank you, sir.
Thank you, sir. Thank you, one and all.